here with you today. Okay, I'm Bilge Karabacak. I am a program chair at Franklin University. Franklin University is in Columbus, Ohio. This is yet another human factors presentation. I saw some other presentations and talks in the CAE forum resource page on the CAE community website. So I am intrigued by cognitive biases and their impacts on cybersecurity, decision making. After seeing some articles on this subject, and this subject also resonates me because I was a victim of phishing attack 2 years ago, and several emails were sent from my account without my knowledge, and it was a it was a bad experience for me. In this presentation, this is the scope and agenda. Basically, this is an interdisciplinary research. I am not alone in this research. I am researching with Kelly Barksa-Renner, who is a program chair at Franklin University. She's a psychologist. She has a PhD in psychology, and this is the preliminary research to clarify the exact nature of the problem. So we reviewed both academic literature and also in the industrial resources. We had some initial questions like, how do cognitive biases affect cybersecurity decision-making? Is it possible to address cognitive biases to improve cybersecurity decision-making? If yes, how? I admit we couldn't find answers to these questions. Actually, we have some interim findings, and I will share these interim findings with you today. And we have some thoughts and also some future research direction. I will share all of them with you today. So let's start with some known facts. These are very famous, popular quotes, right? Everybody, I think, here know this. We saw this in every cybersecurity conference, and those are cited highly. Prevention is impossible in cyber defense, period. So this is an adamant fact. And here the question is actually why. So those professionals and these guys actually sharing this fact, but why is that? Why prevention? Why is this prevention impossible in cyber defense? To answer this question, actually the answer to this question is both easy and difficult. So at this presentation, at this page, Bruce Schneier, the famous cryptographer and information security expert, tells the truth, tells the importance of human factors in cybersecurity. So if you think technology can solve your security problems, then you don't understand the problems and you don't understand the technology. This is right. So, and only amateurs attack machines, professionals target people. So I think here there are two different and closely related facts about human factor. The first, we are the source of almost all kinds of vulnerabilities in cybersecurity and information security, whether it's a technical or non-technical vulnerability. The second fact is that we have some intrinsic, inherent features that make us vulnerable in decision making. So this is something because of our mold, right? So when when we see this Verizon's data breach investigation report, this is the latest report. According to this document, 82% of security breaches involved a human element. So on the user side, end user side, computer users have the potential to make mistakes and a tendency to circumvent security rules, right? So on the system administration side, system administrators may forget to patch a critical application, as we saw this in Equifax 2017 breach, and or system administrators may set easy to guess passwords, as happened in 2020 SolarWinds breach. You remember that password they assigned for that update server? It was a complex password, right? Uppercase, lowercase, and numbers, but it was SolarWinds 123. So, and C-suite, even C-suite, C-level executives contribute to the security breaches, as we saw this also again in Equifax breach. Mistakes made by software architects and software developers are, called software vulnerabilities. These mistakes might not strike to our eyes as a human error at first, but when you check this graphic, so it shows number of CVs per year. So these guys are the driving force behind these CVEs. You see how CVEs are rising as a result of flawed coding and design practices. So for the first quarter of 2022, number of CVEs are like more than 18,000, and which will likely eclipse the number of CVEs, total CVEs in the previous year. So a CVE is not an act of nature. They don't occur naturally, right? So there is a human act behind each and every CVE. So all security breaches involve a human element, directly or indirectly. And to me, human element is not 82%, it is 100%, right? And we can confirm this fact by referring to the definition of computer in Oxford Dictionary. So a computer is an electronic device for storing and processing data, typically in binary form, according to the instructions given to it in a variable program. So we make software vulnerability, we make software vulnerabilities by providing vulnerable instructions to the computers. Okay, let me switch to chapter 2, our brain capacity and distractions. So after these well-known facts. So this is an old cartoon, so it dates back to like 2009, 13 years ago. So this is a cartoon from The Economist. When I saw this cartoon for the first time several years ago, my thought was like, cybersecurity is the fifth domain of conflict. It is an asymmetric domain, things like that. So not nowadays, but after starting my research on cognitive biases, I started seeing different things in this cartoon. In Thanksgiving holiday, I was in Wilmington. I visited the USS North Carolina battleship. I saw the offices, hospital, kitchen, and several places in this battleship. I imagined the crew at the time of conflict and kinetic war. So their brains were filled with mission and orders. Their bodies were filled with adrenaline, and those are all a great combination of concentration and focus. And this is a typical view of our tables in our workplaces, right? So we have lots of distractions. Sometimes we spill the coffee on our keyboards. our phones frequently distract us by sending some notifications, some new messages, thumbs ups, likes, updates. So it really does not matter if you are a cybersecurity expert or software developer or a C-level executive or an end user. Our tables are similar. So our brains are actually filled with tasks, business tasks, and also everything else. So let me elaborate on this. So as a computer user, for example, from the end user perspective, our brains are filled with many different things that come from our work environments, some job responsibilities, but those are not the only things. In addition to those job responsibilities, there are many other personal tasks, emotions. In addition to distractions, there might be some stress, some fatigue, some burnouts, and don't forget this. There might be something about cybersecurity. Don't open suspicious attachments. So among all of these feelings, tasks, emotions, there is something about cybersecurity from the end user perspective. Don't open that suspicious attachment. So it is a very minor item in our brains. And on top of this fact, I should tell you something else. Actually, our brain capacity is limited. It is not an infinite resource, and it fills up pretty quickly. Right? So at this point, let me talk about cognitive biases. This is chapter 3. So cognitive biases are consistent and predictable mental errors caused by our simplified information processing strategies. And this is a definition by a psychologist. Heuristics and cognitive biases are different things, but it is not always easy to differentiate them. What may be considered a heuristic in one situation can be regarded as a bias in another. And I saw this while we were doing our literature review. So a heuristic is a tool for making decisions quickly on limited information, whereas a systematic error that results from the use of a heuristic is called cognitive bias. So for example, suppose you see 3 people running away from a crime scene, okay, while other people stand around. Suppose those 3 people are a black guy, a black woman, and a white guy. So a heuristic is assuming that one or more of the people running away was involved in the crime. A bias is assuming it was the black guy. So this is an example to show the difference between heuristics and bias. So heuristic and biases are not the weakness of humans, instead characteristics of psychology to help us survive in our complex environment with limited cognitive resources. So this is something from the second article here, an interdisciplinary research performed by a psychology professor and information systems professor. Okay. So Kelly and I reviewed 17 papers and industry blogs that are at the intersection of cybersecurity and cognitive biases. And we identified 37 unique cognitive biases from these 17 articles and blogs. This is the complete list of those cognitive biases and also heuristics. So you see the champion is the availability heuristic. It was used 11 times, and then second place is the confirmation bias and the anchoring bias, framing effect, and so on and so forth. Let me provide examples to first 3 here. Let's start with availability heuristic or availability bias. So this availability heuristic relies on immediate examples that come to a person's mind when evaluating a specific topic or decision. So the availability heuristic can affect C-level managers' decisions. For example, some C-level managers may base their decisions on what they see and read in media outlets. So let's assume that Leonardo is a CISO and he frequently checks tech news, Twitter, and he watches television, and he is really interested in hot topics in cybersecurity. So like AI, he says AI, big data, zero trust, blockchain are all new big things in cyber. He is filled with this information, with this data. But 2 months ago, IT manager said to him, what we really need is an EDR solution. Phishing attacks are in rise. But Leonardo bases his decision based on what he watches and what he reads, and he just forgot what IT manager said, and he just focused on AI, big data, zero trust. But there is a big problem in this company. Their EDR solution is old, or that there is no EDR solution. So this is an example of availability heuristic that affects this CISO. For confirmation bias, so confirmation bias is the tendency to search for information in a way that confirms or supports prior beliefs or facts. Assume Joe is a server administrator and a database server was very slow, and he upgrades the server and he is now fast. But after several weeks or months, it slows down again. Now, at that point, because everybody in this organization single out a server as a slow server, those guys tend to connect everything to the slowness. So, for example, after that server slows down again, network administrator Jack says, check your hardware, it is not because of the network. Database administrator says, database is doing okay. IT manager says, Joe, please check your server. Everybody focuses on the slowness of server. Nobody tells nothing to security administrator, and server administrator Joe is just confused, and he just tries to solve the problem. So here you see actually maybe there is an ongoing security breach, and hacker might have built some covered channels, and there have been some they have been maybe stealing information. So as I said, everybody single out this server as a slow server, and everybody focus on the slowness of this server. And the third one in the list, the third frequent bias in the literature is anchoring bias. So anchoring bias is similar to confirmation bias. So it occurs when people rely on too much on the first information when making decisions. So for example, in this company, Steve is the data entry operator and Mike is a system administrator. So Steve heard that Mike is the new system administrator. He's a recent hire, okay? And he receives this email from Mike. Actually, this is a spoofed email, and this is a phishing email. So, hey, Bob, I am the recent hire of the IT department. My manager asked me to reach out to you and some other operators and help you reset your password so that our system will be more secure. Please follow this link to reset. Please reach out to me for any questions. So here, the first information is, yes, a guy was hired by the IT department. Steve knows that. And then Steve, the second information is I received an email from Mike. The third information is Mike's manager is a brilliant leader. So the fourth information, I am not alone. There are others. Fifth information, Mike dropped his phone number. So he is so helpful. And sixth information is, so it's also an inference, I need to reset my password to help my company. So you see, Steve uses subsequent information to confirm the first information to make the first information get stronger. So as a result, cognitive biases and heuristics contribute to the oversight and negligence in using computers, developing software, designing software, as well as administering networks and systems and servers. So they might be considered as the potential root causes of malign decisions in cybersecurity. The Cognitive Bias Codex is a practical and interactive diagram that shows more than 180 cognitive biases grouped into 4 categories and hyperlinked to Wikipedia articles. So probably you see this before, because this is one of the most frequently shared diagrams on LinkedIn. I also saw this diagram for the first time on my LinkedIn timeline and shared by one of my connections. So there are some major contributions of this diagram. First of all, the grouping and subgrouping. There are 4 groups and several other subgroups here. This is a nice contribution. The second contribution is collection of many biases into a single interactive diagram. And the third contribution is each cognitive bias or heuristic has a link to a Wikipedia page. So actually this diagram democratizes the concept of cognitive biases. Cognitive biases have gained popularity among cybersecurity professionals and business leaders in the past 3 years. I think the Cognitive Bias Codex popularized cognitive biases among cybersecurity professionals. So the driving force behind this popularity is probably the Cognitive Bias Codex, because when you check these articles, you'll see that most of them have been written in the past 3 years. So you see several companies here. For example, KnowBe4 is the biggest enterprise for security awareness training and simulating phishing attacks. There are several other security companies, and an article from the Forbes and an article from the SC Media, and you can find many other articles about cognitive biases. So this might be the funniest page on this presentation, but talking about cognitive biases makes me feel like I have found the meaning of the life. I feel like I'm enlightened and I solved the biggest problem of cybersecurity. No offense, this is how I feel, but I got this feeling after I read these industry blogs. Yeah, I guess many industry professionals are feeling the same way. So, for example, when you see this quote, I feel like, yeah, I know. Okay, when I see this one, yeah, I know. The only true security system is the one that is powered off blah blah. Yeah, I know. But anyways, if you think technology can solve your security problems, yes, I know this, and also I know this. Amateurs attack machines. So this is how I feel when when I start working on studying on these cognitive biases. But apart from this funny page, actually there is a really big research gap here. The research gap is huge, and we need to study with cognitive scientists and psychologists to develop to develop solutions to this problem. So there is a big difference between the views of academia and industry, and this is not something surprising. So for academia, they think this is not an easy problem. It's not easy to address cognitive biases to improve cybersecurity. Embrace cognitive biases as functions to help us survive in our complex environments with limited cognitive resources. And they suggest interdisciplinary research, and I found many interdisciplinary research. On the other hand, industry industry recognize cognitive biases, but they patch that human vulnerability, and that's all. So they say in their blogs, like, industry, eliminate these cognitive biases and you will be more secure. But it is not that easy, actually, because there is an elephant in the fridge. So if you want to put cybersecurity in your brain, in our brains, you have to put something out of this fridge, right? So that is not an easy problem, actually. And whack-a-mole game is another good metaphor to for these cognitive biases. So you can hit on the head of that mole, and you can just make it disappear. So I will not click on that link. I will not click on that link, and you can be successful, and you may not, and you will not click on that link, and cybersecurity will be great. But another mole will appear, actually, and will forget your anniversary. So there is as I said, a big problem here, and there is a really important interdisciplinary research area. So at this page, starting with this page, I want to share some literature with you. Here you see, actually, I will provide a subset of our literature review because of time constraints. So here, the first author or authors say that companies should consider psychological factors while developing security policies. The second author, Wiederholt, who has a PhD in clinical health psychology. Psychologists could help achieve a higher level of cybersecurity by understanding the factors behind the perception of risk and rewards, introducing cultural and behavioral shifts, reaching out to the public through social networks to raise public awareness, and educating different types of employers in the cybersecurity workforce. Those are all important suggestions. And these authors propose the term cyber fatigue, and they are from different perspectives, actually. This is a multidisciplinary review article that covers research from management, psychology, and information systems domains. For example, here you see they suggest a 4-component model of cybersecurity fatigue. An employee who is tired of being told what to do may express exhaustion at the very mention of cybersecurity or any cybersecurity policy. So this is, in this sense, their fatigue is advice related. By contrast, if an employee is tired of having to change at least one system password every few days, their fatigue stems from the often repetitive actions, and this is related with actually action fatigue, and they argue that can be 2 types of cybersecurity fatigues: attitudinal and cognitive. When an employee performs a malicious act, practitioners should determine whether it is the advice or the action related, and then whether the disengagement is attitudinal or cognitive or both. So this article is important, an important review article, and because they provide a framework to understand the behaviors. And this is another article, and this is also actually an interdisciplinary article studied by 2 psychologists and 3 computer science professors. And they start with hackers and they analyze the cognitive processes that underlie the detection and exploitation of vulnerabilities. And then based on this analysis, they try to develop a theory for cybersecurity expertise and training. So this is just an introduction of their research. So there were no findings, and they just introduced their ideas, preliminary ideas with the others. Fading effect bias. There is a bias called this fading effect. So fading effect bias causes unpleasant events to fade faster than pleasant events. So at this blog page from National Cyber Watch Center, Dr. Habib from the University of Maryland performs a practice for addressing this fading effect bias. He injects humor into his information security risk management classes in a flipped classroom setting. In their discussion assignments, students were rated on their humor they injected into the discussion and how they engaged their classmates. So this is a really nice example of addressing cognitive biases. Cognitive biases with red in this list are the ones directly or indirectly associated with communal thinking or group thinking. There are others such as obedience to authority, bystander effect, group thinking, and Abeline paradox. So group thinking is very important in addressing cognitive biases. And there are several articles, they emphasize the importance of collaborative learning and changing behavior communally in an organization. So here you see 2 of those articles, Zani et al. And Hong et al. So those are also important articles in this domain. Other than that, at this page, that actually there are other articles that we reviewed, but because of time constraints, I don't include them in my presentation. And I will talk about early thoughts and future research directions in this last section of my presentation. So the question should be how to improve cybersecurity by embracing cognitive biases. So there is no such thing like preventing cognitive biases. Those are intrinsic human feature. So the right question is how to embrace them, how to acknowledge them, and at the same time, how to improve cybersecurity. So this is our roadmap with Kelly. So first, fundamentals, prioritization and acknowledgement of biases in cybersecurity, and development of high-level theoretical approach to address them, maybe to embrace them. And the second one, awareness, some simple yet inspiring cognitive games to be developed by psychologists. So they don't need to be in the cybersecurity domain. The goal is to demonstrate how our minds use shortcuts in certain situations. And then training development, cybersecurity training, focusing on communal and group learning. So our topic will be social engineering attacks. And we will, in this training, we will focus on group interactions. We will include cognitive experiments for awareness of the topic, and it will be a case study-based training. So this is our roadmap about this topic, our future research direction. And I also want to talk about this prevention and detection as a last topic in my presentation. So this is another quote from Bruce Schneier: "You can't defend, you can't prevent. The only thing you can do is detect and respond." So true. So I want to elaborate on this quote. So first thing, total prevention means 100% security is not possible. Prevention is ideal, but detection is must. So prevention and detection are equally important. Every successful detection is preceded by a prevention failure. That is obvious. And every failed detection is a potential disaster. So this is the most important part. Every failed detection is a potential disaster. And we saw this in this SolarWinds breach. So after the first access, initial access, it was a prevention failure. 9 months passed, and the announcement by CISA was made 9 months after the initial access. So there were many incredible numbers of detection failures here in this 9 months. So we saw this. Every failed detection is a potential disaster, and this is actually realized in the SolarWinds breach. So for prevention, this is an photograph I found for the prevention. So God help us, and we should do our best and good luck. These are some keywords. When somebody tells me prevention, I can say this: God helps us, do your best, and good luck. For detection, however, we should be like a radar. So we should detect all incidents, and we should do we should detect as soon as possible. But the difference here is the contribution might be root cause analysis to improve prevention. So this is my 2 cents for this detection. So root cause analysis to improve prevention. Let me give an example. So there is an guide by NIST, Computer Security Incident Handling Guide, right? So in this figure 2-1, communications with outside parties. So we should add cognitive scientists to these parties, I think. And the second figure here, incident response lifecycle. So we should add this. We should include root cause analysis by cognitive scientists for most incidents, I think. So those are some early ideas and thoughts about this. So I think this is the end of my presentation. So this is the last page. I want to just recommend this resource. If you are interested in this topic, I really recommend this book, Cyber Influence and Cognitive Threats. I learned a lot from this resource, so I just want to share this with you. So thank you for your attention today, and I am ready for discussions and questions.
All right. If you have any questions, either you can just drop them in the chat or you can unmute yourself.
Any questions here? I'll stop my share.
Hi, this is KJ Haywood. I am an adjunct professor at Collin College here in Dallas-Fort Worth area. And I wanted to go back to the latter part of what you just discussed. And that was, I think it was your recommendation or suggestion and reference, and I didn't catch it. I was trying to take notes as quickly as I could. But you had discussed the NIST SP 861, then you talked about the IR life cycle, but then you had something in reference to root cause, and I didn't catch that.
Okay, thank you for this. KJ, so let me share my screen once again. I'm just share. Is that this one? So root cause analysis by cognitive scientists or psychologists or social psychologists.
Right. Can you expand a little bit on that, please?
Oh, it might be based on an example. For example, there is an incident caused by a social engineering attack. So some of your staff employees just clicked on a link. So it was like a phishing email, and so there is many technical issues, right? So there will be some detection and analysis and containment, and those are all technical things. So system administrators, server administrators, security administrators will work on that, and also maybe digital forensic analysis will come in, and they will just check, they will perform the analysis, and there will be a post-incident activity. So why that happened, and from technical perspective, they may upgrade their EDR solution, they may upgrade their antivirus solution, they may provide some security awareness training, they may update their policies, so on and so forth. But what really happened on the user side, why they clicked? So what I suggest is, like, from the cognitive perspective, from the human perspective, some cognitive scientists may interview with those employees and just try to understand what happened on their side. What are their stories? What will they share with those cognitive scientists? And what can be done to improve their capabilities in terms of in the future, what can be done to prevent them clicking on the links on phishing emails. So this is just an example from an kind of a case. Is that clear?
Yeah. I think what, if I'm understanding what you're saying, is that I understand what root cause analysis is in general, but from a cognitive perspective, the ideology is that you're sharing that maybe from a scientific perspective, right?
Yes.
From a psychological perspective, you're looking at the psychology, the cognitive thought process of what went into each person that was involved, right?
Yeah, exactly right.
That, okay.
Exactly right. And then, yeah, you're welcome. And based on findings, potential findings, maybe improve the training material, improve some other things related with some flyers, maybe some other broadcasts, some websites associated with security awareness, those kind of things. So there should be a connection between those thought processes and maybe training material.
I have a question. I'm Joseph Herbst. I teach at Turin University. I am not a cybersecurity person per se. I'm an engineer, and my interest is more on the technical basis. And my question will lie on what technical level of expertise is needed for what seems to me three components of what you presented. The first one is preventing attack. That's almost purely technical, almost. The second part is the forensics to determine whether the cause of the attack was either technical or human. I'm using simple terms. So now when we are training students to get into this, how important is it in all three of these venues to fully understand the fundamentals of the engineering that goes into either the computer, down to the basics of what a computer is and how an attack takes place, versus software, how software gets put together and how an attack takes place. And then on top of that, you have the human part, which is the phishing and all of those type of things. So at which point should we emphasize what in their training to be prepared to be able to do all three parts?
Okay, thank you, Joseph, for your question. So I think all of them is important, but technical background is very important. So that is so important. So, but also there are different roles here. So from end user is different than system administrators. Those are different than cybersecurity administrators, maybe. So there are different roles and different things here. But from technical perspective, technical knowledge is so important. So without technical knowledge, those human domains on its own will not be so beneficial, I think. So I am also coming from technical perspective. So I worked for the industry for 14 years, and without technical knowledge, it is quite difficult to proceed in the cybersecurity. This cognitive perspective, this human side should be an add-on, but should really be well studied, should be studied well, and should be provided as an add-on. This is my this is what I think.
The experience that I have, and again, like I'm saying, this is not my issue. It's not my field, my training, but whether the knowledge of the tools, and there's a plethora of tools all available to come prevent, analyze, forensic, it's a whole mishmash of things versus the fundamental technical issues. Like almost every attack really takes place either in assembler or it's in the hardware between the processor and the RAM. And if you can have people trying to attack, but if it doesn't get into the processor and the RAM, there won't be an attack. It can't. The processor doesn't execute the instruction. There is no attack. On the other hand, when you fully understand software coded versus interpretive, you're always vulnerable on the interpretive side. So then just shut off interpretive possibilities. Then you guided all the problems in the coded side, and coded side is much easier to detect. But it doesn't seem to me, whenever I have these discussions, I get a lot of alphabet soup of all the different tools, this, that. But I said, but the bottom line still is this: you can only have an attack in these two places, and that's what you have to prevent, or that's what you have to detect after the fact. Does that make sense?
Yeah, but actually, yes, but it is easier said than done, actually. So the reality is quite different. So the entropy in cyberspace is like growing. So there are many complexities. So in micro level, there are codes and software like hardware, but when you see from a broader perspective, there are hundreds, thousands of computers, switches, devices, human interactions, communications, protocols, software, and applications, thousands of different applications with hundreds of vulnerabilities. So it's a complex world. So it's not quite easy to make that prevention.
I understand, but even on the forensics side, does the forensics go back to the core issue, or is forensics just a superficial issue and you can prevent it by training people to do the things differently? But that's not where the attack took place. The attack really took place on the bottom.
Yes.
So if I wanted to hide my attack, I would address the fact that the forensics will not find me while I'm still embedded deep down, and you'll never detect me, because I approach it from a human forensic point of view rather than a technical forensic point of view.
Yeah.
This is KJ. I just wanted to jump in. I think you're both, and I'm sorry, can I get your name again? I missed it.
Joseph.
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 Joseph,
Herbst.
hi, Joseph.
Yeah, hi.
I
It's a
think
common name. Everybody knows Joseph.
mine is just 2 letters, so you can't forget that. I think there's an element of both here. At least from my experience, I've worked in cybersecurity for a number of years, quite a few, and I don't want to age myself, but I know that when incidents do occur, when I've had to actually conduct a forensics, right, and process, I've had to actually do both unexpectedly, right? I mean, I'm now teaching, cyber psychology, which is a whole new industry that we're delving in. But I think it's a human element and it's a technical element, right? Because as a professional, especially working in from a technical perspective, you can have everything absolutely perfect as far as the tools and the applications are concerned. Even your platforms can be absolutely secure and perfect, but there's that human element to it that, did they actually, update the software? Did they identify the vulnerability? Did they actually follow through with that particular vulnerability once they've identified it? Did they walk all the way through the processes and the procedures in order to manage that particular software application from a security perspective? And that's where the human element comes in. So I think we're talking about basically apples and apples here, not necessarily apples and oranges, that both can be a part of an entire forensics investigation process. And then what was the breakdown? Was it human, as you said, or was it actually a technical breakdown? Did the software just not get updated? Was there an actual exploit that occurred and they actually were able to get in?
This is Paul here, right? Both of you guys are correct, but there's tools that can do all of this for you. 99% of exploits that happen in code is because of bad coding, right?
Yeah.
And very few schools teach secure coding. You cannot find a school out there that teaches secure coding. So most of the students come out of computer science or cybersecurity knowing how to write a program, but how do they secure that program? How do they secure that app?
That's
right?
my question. That's my point.
That's the root issue right there.
That is my point.
So part of what I would like to see, as I'm happy that you're doing this, is maybe the CAE community, maybe we come up with some team and come up with some type of course that talks about secure coding and teaching faculty how to use these tools, right? Because not a lot of our faculty know how to use the tools to actually write code and show students how to secure it, right? So in a forensic side of things, the attack is constantly going on in the background. So if you don't have the right tools to capture, to trace, to save, and to replicate what's going on, you may never find that vulnerability. You may never find that exploit that's going on. That can sit there for years, right? Because folks don't know what's going on, right?
That's my point. My point is precisely that. For example, if you bring up coding, I'm talking hardware side or the software side. Coding, who doesn't use libraries that they get from someplace? The whole world screams open source, right? And there is nothing that's more vulnerable than that, but the coder themselves will never know that they shouldn't use that, because when they bring in that other library, they have no clue and no way of knowing what they're bringing in, but they don't understand the concept, because they don't understand when they build a program, all they hit is build in Visual Studio and poof, and there's the program, and Git got everything together. And this guy said, add this link to this library, and they produced a program. They did a fantastic job. And the vulnerability only shows up when there's a few $1 million missing 3 years down the line and has no source. And but people, if they don't understand the idea of what it means to link code, then they have no sense of feeling how vulnerable they are with what they're doing.
Well, that I think that's a challenge that us as faculty. I mean, I'm a teacher, right? I do cybersecurity stuff on the side. Us as faculty has to, find a way to bring that into our classroom.
That was my question. That's exactly my point. I'm fighting with everybody
I'm fighting too.
Because they have a checklist. They have a checklist of all the things that the students have to know with a bunch of alphabet soup. They have to know this and that, all the tools, and yet
It's
they
cool.
could be the cause of the problem.
Yeah, this is Rhonda Chacon from Purdue University Global. And oh man, you give me chills because I came from a computer science background, was in industry for 28 years, building software products. And it took me a while. I proposed a secure software development and quality assurance specialization. And I proposed it a long time ago because, you know, if we look at just coding, secure coding's been around forever. And the problem is just what you said, academia is not stressing that in an entry level programming class, you know, and that's kind of where it has to start. I think so. We're separating, you know, developing software from developing secure software, you know, and it's one and the same. And that's why I created a 5-course micro-credential, and I on purpose use C and C++ for the coding sections, you know, but, you know, we take the SDLC and, you know, start with security at the requirements stage of things, all the way towards, you know, getting product out the door and maintaining it. And I've struggled like you guys, and I don't know how we fix it because there's all these open source tools. Let me grab this code. Let me grab this API. So-and-so said this is good. And we're in this situation now where we have the cybersecurity industry. I mean, because to me, that's where it starts. In the software.
Yeah, and this is Paul here again. I'm from RCDC in New Jersey. So one of the things I am trying to do is because we have a lot of our students actually come back and speak to the current students. And one of the things they always talk about is secure code, right? And I think part of the challenge is how do we, like you have a course, how do we kind of get maybe our bosses or whoever, the deans or whoever, to understand that this is critical, right? Because if you don't know it at the entry level, if you don't know it from jump start, it's going to be hard for them to learn it later on, right? So
that's right.
How do we maybe somebody has a platform somewhere that we could actually share or collaborate with and say, hey, look, maybe you could use my platform as a pilot project or something like that, where we could actually have our students log in and actually do it from an isolated environment where they actually get to see how this stuff really works.
By showing mistakes, by showing insecure, like showing a vulnerability that's been exploited and take it down to the code level.
Yes,
Is that what you mean? And say,
yes.
say, this is what can happen, and this costs the company this much money plus reputation. So, and then circle back to, hey, let's learn about what software development is, you know, and how it needs to be secure and all of that stuff.
My emphasis at this stage, because we can't change the world,
No.
but at least and this is my question, realistically speaking, should the person who's going to be a cybersecurity person with rolled up sleeves, not an administrator, but the guy who rolls up the sleeves, who eventually becomes the administrator, should they at least understand the vulnerabilities? You're trying to prevent the vulnerabilities, all the credit to you, okay? But we're now training, quote, cybersecurity professionals. I want them at least to know what a computer is. I have the feeling that if I ask the staff a simple question, what is a computer? I've never yet gotten an answer, which says that it's binary instructions sitting in memory that a processor executes, and the processor decides which is the next instruction to do. And the attack becomes when you trick the processor to execute the bad instruction instead of the good instruction. And this is the most crucial fundamental point in cybersecurity. Without it, it almost doesn't happen. I'm afraid to ask that question at a staff meeting because I won't get that answer. And then I say, well, how are my students supposed to know that answer? But I think without having that fundamental level of understanding, along with assembler code on the side of that,
Yeah.
that's where the attacks take place. But it could be that I'm just wishful thinking. I'm an idealist or whatever. Maybe practically speaking, it's not that important. I don't know the answer, but the people out there should know the answer, and they should guide us to let us know how much should be 10%, 15%, 30%. I would kick out all open source from the beginning. Just never allow it to ever occur on a computer that has to be safe. But I don't have that ability to say, but at least people should understand it if they're gonna be in the business. I could be wrong. Maybe I'm over, like they say, somebody with a hammer, every problem is a nail. I'm a technical guy. I've done that all my life. So to me, every problem can be solved with technology. Okay, fine, maybe so. But obviously in this discussion, that's not the case. Go fix humans, but it's easier to deal with machines. But from a training point of view, the question is, am I overemphasizing this issue, or am I just let everybody do, the standard alphabet soup?
No, that needs to be stressed more.
Yeah.
And you have a good point. Those that have come from in the embedded world, they understand this, I think, really, really well. What you were talking about.
Yeah, well, I know it because I did it.
Yeah,
I
me
lived
too.
it. But
part of the challenge with academics is, and I see this, is you have people that are strictly academics and they don't have the expert level or experience, the real world experience that they're bringing into the classroom. That practitioner's experience is not there. So you're asking someone to, hey, look, someone that did a research on something as opposed to someone that actually did it, right?
Yeah.
So the person that did it knows what to do to show the students exactly how it works.
Right.
But a person that researched it could tell them how it works, right? This is all the different things you need to know about. But hey, look, let's get down to that expert level. And most of you guys know that a coding, all right, for you to find vulnerability in code, if you don't know code, you're not finding the vulnerability in code, right? Even if you scan it and you find it, 90% of the times you won't know how to fix it because you don't know coding.
And I can say, from a person who is new to academia, who's coming from the workforce in security, you have people who are in positions that don't. I mean, to be, very transparent, you're placed in a position where you are required to review vulnerabilities and have no experience in understanding what code is, right? Or how to code.
Right.
So I think, all the points that were made today are right on target as far as, the real life application, which is that we need to have, our coders understand security, but we also need to train externally, right? The industry itself needs to, there is a behavior change. And yeah, they have tons of cybersecurity platforms out there and security platforms that are beautiful, and they're